Good morning, students of class 12. It's very good to see you again. I hope that you enjoyed my lecture, which I gave you on sucrose, maltose yesterday. I taught you how to make the ring structure of glucose and fructose and how they combine through different bonds and how is 1,4 glucosidic linkage reducing and 1,2 linkage is not reducing. The availability and inavailability of free aldehyde group to react with filling solution and tolerance reagent. Today we will proceed. We are done with carbohydrates. Carbohydrates is a very much important topic, I tell you, okay, for examination point of view. And many students have done very good job in showing me. A good mentions is Hafsa. Hafsa showed wonderful disaccharide formation. Huda, there was nice pictures of different from her previous school books, which shows the interest, the value of interest in the lecture. Today's lecture is about amino acid. Before I proceed to amino acid, I must tell you that we are going to conduct a written test of carbohydrates and their biological importance. The test will be on Friday. So whenever you're free, take your books and start learning them. Thank you. Today we will proceed with the next lecture, and this is amino acids. All right? Amino acid is our today's lecture. And it is my favorite topic because I like amino acid. As you guys like carbohydrates, I like amino acids. Amino acids are building block of our body because they make protein and the protein make us. Our entire body from our head to toe, everything is basically protein. The way blocks are used to make buildings, amino acids basically they make proteins, and from proteins we are made. So amino acid is a special class of organic compound actually, and as students of chemistry, we are going to deal with the chemical aspect of amino acids and not so much the biological aspect. So what are amino acids? Just like carbohydrates have two functional groups. Okay? What are the two functional groups of carbohydrates? If you think aldehyde and ketone, that's a wrong answer. No. Carbohydrates have aldehyde and hydroxys or ketones and hydroxys. One carbohydrate at the same time, as far as the monosaccharide is concerned, cannot have both aldehydic and ketonic group together. All right. So just like carbohydrates are, they have a double functional group of aldehyde and hydroxy. Amino acids also have double functional group, and that is COOH, the carboxylic group, and the amino group, the NH2. So amino acids, by definition, are the bifunctional group compounds which contain bi means two, which contain carboxylic group COOH, and you know carboxylic acids already from the class 9, from the ninth chapter, and amino group NH2 when both of these groups are present on a chain of carbon atoms. The compounds are known as amino acids. These are monomers which combine to make polymer. The polymer is called protein. And these amino acids are bonded through by a bond, just like monosaccharides are bonded through glucosidic bonds. The bonds through which amino acids are bonded are called peptide bonds. So polypeptide, which means a lot of peptide bonds. All right. I explained yesterday glucosidic bonds. Today I'll explain the peptide bonds. I hope you will enjoy the lectures of today as well. Now, how we represent, to understand any organic compound, we must we must have a general formula of it. Here we go. Carbon, carboxylic group, amino group, All right, you can see that. This is important for, this is a necessary, essential. A compound will not be called amino acid if it does not have at least minimum one carboxylic group and one amino group. R represents alkyl group. Now that could be H for the first amino acid. That could be methyl or ethyl or propyl and so on. Depending upon the R, you can have a longer and longer and longer chain. All right. And then the names will also be different. So let's move further and uh, first I'll teach you the major types of the amino acids. So there are three types: the neutral amino acid, the acidic amino acid, and the basic. So by neutral, I mean one carboxylic group, one amino group. If any amino acid contains one carboxylic group, one amino group, that's called neutral amino acid. Alanine, you can see that alanine, just like carbohydrates name end on O's in chemistry, the amino acid names they end on ene, I-N-E. So alanine, look at the alanine. Where R, there's CH3. Okay, so alanine has the CH methyl group. So you can see as a student of chemistry, it is 1, 2, 3, 2 amino propanoic acid. The IUPAC name of alanine is 1,2,3, 2 amino propanoic acid. I'm not sure. I think alanine is one of the essential amino acids. One of the essential amino acids without which we cannot survive is alanine. And alanine is 1, 2, 3, 2 amino propanoic acid. It contains one carboxylic group and it contains one amino group. All right, and where the R is, there's just one methyl group. So this is alanine, neutral amino acid. How about this? This is valine. Okay, valine has the isopropyl group at the R, and if at the R there is H, just the H, it's called glycine. Glycine is the simplest amino acid. In the glycine, you will not find CH3 here. It will be NH2, CH2, so glycine. Glycine, alanine, valine, they all are in the essential amino acids. So you can see neutral amino acids include glycine and alanine and valine, all right? And the R can change, all right? If you see your textbook and you see a page number 228 and 229, you will see the two pages are filled with charts. These charts tell you R and the name and the prefix. Basically, amino acids are more shown with prefix. Like if it is alanine, it is shown with the L, A-L-A. Okay, valine is VAL, glycine GLY. You should better go to the book and check there. The first column will show you the name of the amino acid. The column 2 will show you the prefix that we use for the amino acid. The column 3 will show you then the R. What is R? The NH2CH is same. What is R? If the R is H, it's glycine. If the R is methyl group, it is alanine. If the R is isopropyl group, you can see here one, it's valine. So understanding the amino acid with a chemistry background is very much enjoyable. And I will ask you, okay, if I put right here isobutyl, it is called, my friend, leucine. Okay, and isopentyl, it make isoleucine. So glycine, alanine, valine, leucine, isoleucine, they are all essential amino acids and they are neutral by nature, which means one carboxylic, one amino group. If there are two carboxylics and one amino, it will be acidic. Or two amino and one carboxylic, basic. How cool is that? Lysine. Lysine, L-Y-C, L-Y-S dot. It is basically L-Y-S dot. Yeah, lysine is the basic amino acid. And if you guys know lysine syrup, who of you know lysine syrup? It's a very sweet syrup which doctors prescribe to us when they give us antibiotics. Mostly we get the lysine syrup. Right? It contains lysine. This is an enzyme. This is, sorry, an amino acid. Two NH2 groups. Okay, you can see one, two, three, four, five. So two, four, five diamino butane pentanoic acid. One, two, three, four, five. Yeah, two, four diamino pentanoic acid is basically is lysine, one of our favorite amino acids. And the acidic ones are those which contain two carboxylic groups. See here, aspartic acid. The acidic amino acids, they're not shown as INE, but their names have acid. IC acid, aspartic acid, and glutamic acid. So these are all, okay? These are basically the acidic one. If you want me to name this IUPAC, you can do with me. One, two, well, one, two, three, four. Two amino, one, four, butane dioic acid. That will be the name. This is the basic amino, sorry, acidic amino acid, or dioic. They could be trioic and more. Yeah. Now, the amino acid are very much good compounds, and I want you to check the chart, even make the chart as much as you can, because I have seen in the annual examination, in the naming section, they always throw one amino acid, a different one, and the students really suffer how to make it, and they just, okay. So then we have the introduction to the essential amino acids, which is in the textbook: leucine, isoleucine, methionine, threonine, adenine, arginine. These all are essential amino acids, which means that they must be taken in the diet in order to live a healthy life. And if not, then it's called malnutrition. Right? You're suffering. You will get. You will soon suffer from any disease, or your body will not be strong to act against the viruses, such as the coronavirus. So amino acids are very much important. And eggs, my friend, hard-boiled eggs, they provide you all the 10 essential amino acids. So eggs are cheap, eggs are readily available, eggs are everywhere, and you all kids must try at least one hard-boiled egg in the morning in order to live a healthy mental life and also healthy physical life. All right, just imagine one egg of a chicken. This one egg becomes a whole chick. Isn't it incredible? It means it contains all the life making, life sustaining nutrients inside it to make a complete chick. So don't miss on the eggs. Okay, chicken eggs. And remember the poultry, the same egg. If you take the local one and the other, don't worry, just take any eggs. So, what are the essential amino acid? You will write from your textbook. Three types of amino acid: neutral, basic, and acidic. And now we go towards chemistry, which makes them very, very good, chemically reactive. Zwitter ion. So, what is a Zwitter ion? Carboxylic acids are proton donors. OH, H can go out. Amino have the lone pair of electrons. So within the same molecule, it's very, very exclusive for amino acids alone. Same molecule has a proton donor species and a proton acidic and basic at the same time. It's called dipolar nature. So what actually happens? Let me look at this one try. Look at this. This is carboxylic part. Is it? This proton is given to this amine. So NH2 becomes NH3 and we have COOO. This is called Zwitter ion. If you have in your textbook, a big mistake in textbook, page 232. In the reaction, they have shown COOH on both left and right side. The right side will not have the H plus, but the COO minus. A ZWITTER ion is a neutral species in which contain the plus and minus ion at the same time, produced within the same molecule, because the same molecule is both acidic and basic in nature. So please write the introduction for ZWITTER ion from your textbook. Understand how it makes. Carboxylic group loses a proton, and then amino group picks it up, resulting dipolar charged but overall neutral molecule. This is known as the ZWITTER ion. For this reason, amino acids are amphoteric in nature. They both donate and accept protons. So they cannot just donate and accept within themselves, they can also donate and accept with the other molecule. That's why we become big people, because we eat more protein and the protein comes to our body. So I always do this joke in the classroom that if you want to build muscle, you need to eat more protein. So when you are bodybuilding, for example, and you are hitting one muscle group, you are trying to engage it and break it, and the next few days when you eat proteins, the, the body in the bloodstream carries these amino acids and takes them to the part which needs it the most, right? That's how the bodybuilders build their muscles, because uh, on the day they cramp those muscles, they break those muscles, tear them up with heavy weights, and when they eat proteins, the proteins break down into amino acids, they go into a bloodstream, and then they transfer wherever they are needed. So if you are working your biceps, okay, for next 2 3 days, the bicep will keep consuming amino acids from your diet, and then you will have bigger biceps. This is how different muscle groups are trained. Some people have strong right arms and weak left arms. Why is that so? Because they engage the right arm muscles more, and the more amino acids are transferred to those muscles and make them stronger. So it's a very simple rule. All right? Small children require a lot of amino acids in order to become big people. All right? So some people get bigger and strong, and some remain short because of the lack of amino acid in their diets. Now, what is the peptide bond? The words over here don't really matter, so I'll jump to this reaction. Look at this. This is an amino acid, NH2CR. This is a general formula of amino acids. These both are amino acids. Now, OH from one amino acid from the carboxylic group and the H from the amino group, they make H2O minus H2O. Water is released. It's called condensation polymer. Most biological polymers are condensation polymers, and you know what are? Bakelite is also a condensation polymer. So now the bond will be between carbonyl group and amino group. See that? C double bond O and then NH. A bond which combines, joins carbonyl and amino is called peptide. This is a peptide bond which joins just two amino acids. But in protein, they are macromolecules. There are thousands of amino acids. So there are lots of peptide bonds joining different amino acid molecules. So proteins are called, they have polypeptide. So now we go towards the reading stuff. Amino acids in proteins are linked together through an acidic amide group type of bond known as a peptide bond. This bond is formed between amino acid, two amino acids. Okay, if there are more amino acids, this is called polypeptide. So it's linked between carboxylic group of one amino acid and amino group of the other amino acid by the elimination of water. It's called polypeptide. When we eat food, we need enzymes to break these peptide bonds, because our body cannot directly digest or assimilate, use the proteins. It must break down into amino acids. Children, for example, infants don't have those enzymes which can break these peptide bonds. So they have a simple proteins, casein protein from the milk, from the mother milk. As they grow up, their body gets the other enzymes as well. Okay, so essential amino acids that cannot be made by the body and must be taken in the diet. All right, they are very essential not only to making healthy brain and bodies, but also impulses and nervous system. So if you are lazy and lethargic all the time, you don't have the energy, but you're fat because your impulses, your nervous system is slowed down because of the lack of the essential amino acids. So how can we take all the? They must come from the diet. Okay, and you have disease. 10 are essential: arginine, valine, lysine, phenylalanine, leucine, isoleucine, threonine, methionine, tryptophan, and histidine. They come from different protein sources. Fish is a protein source. Fish can might have one amino acids, few amino acids, and may not have the others. Okay. If you are on chicken, chicken might have few amino acids and not the rest of the amino acids. So, what we should do is we should go for a combined protein source. Like we should divide the weekdays. Our parents always do it. Monday, if it's chicken, Tuesday, let it be fish, Wednesday, let it be lentils, dale, or peas, chane, and the next day something else. A mixed protein diet will give us the entire supply of the essential amino acids. And in case if you want to be like fully sure that you don't miss on them, just like me, you can take. I take 3 hard-boiled eggs every morning with green tea. It's a good. It gives lots of energy. So in case you can't take 3 eggs, at least one hard-boiled egg do the job for you. Not the omelette, but the hard-boiled egg. Because omelette, then there's a glycation, other chemicals combined with the nutrients, and then they don't provide that much energy as a hard-boiled egg can provide you. So what do they do in our body? Amino acids play a very important role, a vital role. I mean, without it, life is impossible. When you eat protein-rich food, beef, meat, even milk has protein, wheat has protein. What happens? The proteins are hydrolyzed, broken down into amino acids. Okay. So if you take 1 gram of carbohydrate, it immediately dissolves into calories. But if you take 1 gram of protein, a lot of work is needed. So this is called the good calories and bad calories. Calories from the carbohydrates are called bad calories because they immediately dissolve to give. It is for people who want to lose weight, not for everyone. Okay, if you are underweight, don't miss out on carbohydrates. Okay, if you are overweight and you're going to lose weight, it's called a paleo diet, high high protein diet. I don't know what they call it. So if you take uh, mainly protein as in your diet, you will start losing weight, even if you eat more. Because when you eat more protein, the body has to work more in order to break those proteins. So if you take 100 grams of proteins, I hope 50 grams of calories are used up in order to basically break them down, hydrolyze them into amino acids. The blood receives those amino acids through absorption from the intestinal walls of intestine, the villi, they absorb, suck into the bloodstream, from where it goes everywhere. So what do they do in our body? They make body protein. They go and make your muscles. Okay? Some people are healthy, they have bigger bodies, they have more proteins. Okay? And if your diet lacks in carbohydrates, if the carbohydrates are less, the body will burn up proteins and give you the energy from there. Okay, if our diet is low in carbohydrate or fats, body protein may be transformed into either of these or to use hormones. Hormones are you need proteins to make hormones and enzymes. So proteins are important compound, okay? They make our skin. If you want better skin, you need protein, muscles, hair, and nail. All the vital life processes are in protein, and they make their peptide bonds. Okay, so this is the story of protein. If you want to go further, mostly from 200 to 60,000 amino acids. Okay, they can combine to make the molecular weights of 17,500 to 6 million daltons. Or this is AMU. Okay, Dalton is equivalent to AMU. Okay, AMU is the another name for it is Dalton. So the proteins are vast substances, and they have, yeah. So when they put into acids, then you can get the amino acids from them. This is the protein arrangement showing you the polypeptide bonds. So guys, I think we are almost done with the proteins, and in fact, we have gone into the new topic of protein. Actually, my mistake, my bad. It's not for topic for today, it's tomorrow's. We end our lecture here. Role of the uh, amino acid in human body. So kindly read your book and check this video, and kindly share, and tell me if there's any questions. I'll be very happy to answer. Many students ask me questions, but I make a special video on those questions, which I think will be for greater interests. Like many students would be confused about that. If a student are confused about one question, I answer them immediately on WhatsApp. I don't. But if the question I think like majority people will need it, then I'll go for and make a video on that. This is it, today's lecture, the amino acids. Thank you so much. I hope that tomorrow's topic, which is protein, we will discuss it in the details tomorrow, and it will be good to see how we are progressing in here. So, my dear friends, this was the lecture for today. It is the lecture about the amino acids. Kindly share it and show me. We'll meet tomorrow with the similar lecture on protein. Thank you so much. Goodbye.